Hello, my name is Summer. Here's the presentation of Assignment 2, an S3 Network Simulator. Here are the goals of this assignment. Part 1 is learn the basic concept of an S3 and install an S3. Part 2 is simulate the LTE network using an S3 that you install. Here are my weekly plan. For first week, I will create Assignment 2 page and learn the basic concept of an S3 using 2 days. And I will read an S3 tutorial and create a VM to install an S3 for 3 days. Next week, I will install an S3 in VM using 2 days and run LTE simulation also using 2 days. And last, I will record presentation and demo video using 1 day. And here are my network topology. Here is the radio environment map, and this one is mobility. Next is my starting node of an S3. First is what is an S3? An S3 is a discrete event network simulator for internet system, targeted primarily for research and educational use. The NS project started in 2006. And here are few key points are worth nothing at the onset. First one is an S3 is open source, and the project strives to maintain an open environment for researchers to contribute and share their software. Second one is an S3 is not a backward compatible extension for an S2. It's a new simulator. Next is about an S3. An S3 has been developed to provide an open, extensible network simulation platform for networking research and education. In briefly, an S3 provides model of how packet data network work and perform, and provides a simulation engine for users to conduct simulation experiments. Some of the reasons to use an S3 includes to perform studies that are more difficult or not possible to perform with real system, to study system behavior in a high controlled, reproducible environment, and to learn about how network works. Here are some features of an S3 in contrast to other tools. An S3 is designed as a set of libraries that can be combined together and also with other external software libraries. Several external animators and data analysis and visualization tools can be used with an S3. And it also can use on Linux or Mac OS system too. An S3 is not the officially supported software product of any company. And here comes the part to install an S3. First, we need to install VMware. Here is the website I download. And next, we need to create a VM. And the OS I use is Ubuntu 20.04. I also download in this website. And then we need to set up an S3 environment. This is the configuration I use. And here are prerequisites of installation. Includes C++ compiler, Python, CNAKE, and build system like Make, Ninja, and then it's Git, tar, and unzip too. And here are the commands to download packet. And after you download, you can use this command to check your packet version have achieved prerequisite or not. And here are the results. And next is downloading and build an S3. There are 2 ways to download it. The first way is you can download the latest release as a source code from an S3 website or using Git repository from gitlab.com. And here I choose option 2 to install an S3. And first, you need to download an S3 using Git. And here is the command. I create a file called workspace and clone the file in this path. And after you clone it, you can see the result like this. Next is download 3.39 release of an S3. And you can choose another version if you want. You can just change the command here, then you can change the release you want. Next is building an S3. Once you have obtained the source, the next step is configure the build using the CMake build system. And first you need to go in this file, then configure the RS3 using this command. And here are the results of configuring. Then you can build an S3 using this command. And here are the results. It will take some time to do this step, so just wait for a second. The next one is test an S3. You can run this file to test it, and the result is here. It should be report at all test paths, not fail or crash. Then you can know it is success or not. And you also can running a script. So using this command, then you will get the result of Hello Simulator, and it proves that you successfully installed LS3. And next parts are run LTE simulation, and here are some tools I use to run simulation. First is PyBiz tool. So first you need to install the PyBiz, then bind the Python with PyBiz visualizer, and you need to rebuild an S3 as the like in this part. So after you config, you can see the PyBiz visualizer and Python bindings are on. And we need to have use source code. I copy it from example file. Then you can run the file using this. And here are the results. And you can click this button to simulate your result. Next one is radio environment map. And here I also copy a source code from examples. And here are the file name. Then I added some parameters in this file. I changed the microcell to 7, and there are 3 microcells are randomly distributed in the square area, and 50 UEs are randomly too. And the InnoB transmission power is 46 dBm, and each base station's distance are 0.7 kilometers. And the general model I use is path loss model, feeding model, mobility model, waypoint model, and InnoB antenna model. And here are the code I changed. When you edit your file, then you need to create a REM. And here you can use this command to create. Then after you create, you need to plot your result. So we need to create a script for plot. And here are the commands I used. And you need, if you want to use GNUplot, here are the packets you need to install. And after this, you can use this command to show your result. And this file will be generated after you run this command. And here are the results. And next one is Net Animation Tools. First, you need to install the prerequisites of Net Animation. Then you need to clone the file of Net Animation. Then using this command to build Net Animation, then you can get the animation tool. And next step is create a CC file in the Scratch, and also download the PNG file of InnoB and UE on internet. Then I edit the CC file, and here this website are the source codes I use, and I change some parameters, like I set 6 InnoB and 30 UEs. And here are my code. Here I set the InnoB number and UE number, and I create the nodes, and I configure InnoB mini X. It means the first node start of the axis as X, and mini Y means the start point of axis Y, and delta X means the distance between two nodes, InnoB nodes of axis S, and this is for axis Y, and grid width means each node in one column have how many numbers of nodes. And I set the inner bin node stable, that it won't move in simulation. And next is configure UE. And the difference with InnoB is I set the node bin mobility and UC bound to set the boundary of the moving. And then we need to use animation interface to generate the XML. Then we can have the simulation. And here you can load the PNG of this one you download. Then put it in every node. And after this, you can run this command. And after you run this command, you will get an XML file. Then you can use Net Animation tool to see the result. So first, you need to go to the path you download Net Animation and run Net Animation. And you can click the file to load XML. You can choose the XML you want. And here are the results. And you can don't use the file download, and it will be the icon like this. And if you use the image you download, the icon will be like this. And this is the reference I use. And here you can get the whole information of me to how to make the step I do like above. And here's my whole presentation. Thank you.